Alright, I just want to do a quick update on the Element Enduro project that I've been working on. It's been a few weeks since I posted up a video. Basically, I have the body on, you can see that. There's been a few other changes I've done. But first off, the body is the J Concepts 89 F250. I like it. I got to do a little bit more trimming on it around the wheel wells, but it's a cool looking body. And I did a custom bumper for it. That may change, but it's something. There was no bumper on this build kit, so also the tires are Enduro 1.9 6 clones, and the wheels are the nice blue Enduro, and I got the brass adapters on there. So next up, I did have to put a BEC in this because I put in a 36 kilogram EcoBoost high voltage servo, and it was browning out under high heavy loads, so that resolved it. The ISDT 70 amp ESC wasn't supplying enough amperage. I think it goes up to 3 amps max. The voltage can go up to 7.4, I believe, but still it was browning out, so we wired in the BEC. Also running one of these Z3S mini packs, 2 for like $30. Nice battery. I don't know how long they'll last, but also the XT60 connectors works well. So I did make and you like my wiring? It's not too good. I did make a custom battery tray and use one battery strap for the little battery. It's basically bolts onto the stock cross member for the original battery mount, but I had to take it out and flip it upside down so that I could mount this right onto the frame rail, basically low enough so that the flat surface of the battery tray rests on the frame rail, so it's a little lower. I was planning on mounting an existing battery I had to the side of these rocker guards that I made, these sliders, but there's not enough weight from the motor on the opposite side, so what happens is it basically slants to one side with the weight of this battery. So I'm not sure what to do. I kind of scrapped that idea and went back to the original type of battery tray like this. So that also gets the forward bias back a little bit. Not that these weigh a whole heck of a lot, but so other than that, you probably noticed there's some differences here with the transmission and motor, and I did put a slipper clutch on here. So basically this is the Stealth X with the 11.6, 11.8 overdrive. I never can remember what that number actually is. I have to look every time. And I took they're called their LCG kit from Artful Dodgers. It basically reorients the transmission and the motor and lays it flat, kind of spreads it out, pushes the motor off to the side and the transmission off to the side, and then your spur gear is more centralized versus being standing up. It does come with a plate to bolt on to the bottom of the transmission, and then the motor plate, and then your spur is exposed at that point. What I did not get with this kit was the flat skid, so I had to put some 5mm spacers under this to get it up high enough off the stock skid plate so that it would mount. And it's as low as it can go without hitting the frame rail, so that's good. I didn't see the need to do this flat skid, because when you do the flat skid, I think you have to relocate the upper control arm mounts up higher, and they send you some 3D STL files to print out the mount relocation brackets, but I wasn't feeling it, so I didn't do that. Just left the skid plate as is. But I did replace, and I'm going off on a tangent, I did replace all the rod end balls with metal. Actually, they're brass, they're chrome plated brass. And I got those, where did I get those from? I got them off Amazon. This Clubs Racing scale designed brass pivot balls for Element Enduro. There's 20 of them. I can't remember what I paid, but they look nice, and then they'll work well. The motor is what is it? Let's see. Can't even remember. I think it's a Surpass crawler 5-slot 540 plus V2 brushed motor. It was about $50. I didn't feel like going brushless with this. I had this ESC, you know. I did have some other 5-slot motors which I was not happy with the drag brake on them, but this one has got a big armature and very strong magnets, so its drag brake is adequate now. Comparing it to so I originally, what did I run? I think I had a 16 turn. That is a 16 turn. I was running a 16 turn 5-slot Radon Reedy motor. This one, drag brake's almost non-existent. So I did that. I played that game. Then I said, okay, I'll get the 550 because I want to try a 550. So this is the 12 turn, yeah, 5-slot 550. Drag brake, not great. Maybe if I use it again, I'll change my mind. I don't know. I was running a 20 turn Radon in my CR01. It's nice and smooth. Drag brake's not that great. So I put the CR01 tuned Tamiya motor back in the other rig, and it's smooth. It's got great drag brake, and it's got great torque. I can't complain about that motor. I might get another one. Anyway, back to the Element. When I did this conversion, which I like, I think it's kind of clever, I noticed the drive shafts work. The center metal section was already sloppy with their stocks, positioning in the center. But when you move this, when you add this new plate, this Artful Dodgers relocation bracket, it pushes the drive shafts way off to one side. So in effect, you need a longer. It's extending. It's telescoping out the drive shaft, and so then you have even more play with these metal sections, especially in the rear. Is longer, so it's a longer section, but the front was the worst case. Actually, I had this thing upside down. I was changing out the rod ends, the balls, and the drive shaft just fell apart. It separated, and the center metal piece fell out. So I'm like, okay, well, we gotta fix this. So I had a bunch of different springs, and let's see if I can find one. I don't have them all. Here we go. Some springs I had from way back. Designing something. Didn't use them for anything. Leftover spring. Alright, so these are, I don't even know what the spring rate is or the size is, or I think the material could be just regular piano wire. Anyway, they're not super stiff, but they have a little bit of force. They're nice. I basically cut them in half stuck them inside these plastic drive shafts, and it puts pressure. I don't know if I can show you this. It puts pressure on the drive shaft so it centers it in between. It still has some motion. The front, you're not going to be able to see. It still moves back and forth a hair, and I get full compression without an issue. See, that one's might be bottoming out. I might need to take it out and trim it a little bit, but it does what I wanted it to do. So unless you want to replace these, which I did not want to, because they're decent, they're all metal ends. I mean, they have plastic, but the centers are aluminum. I don't think the RTRs have the aluminum centerpiece, so they're decent. So that resolved that issue, and then the main reason I did this was to talk about the slipper clutch that I installed. There's a couple other things I want to talk about also, but we'll get to that at the end. Slipper clutch. Love this upside down stuff, huh? Here we go. So this is the stock spur gear, and these are V2 slipper clutch, team associated slipper clutch, and they fit right onto that the shaft of the flats. I have all the part numbers, I'll tell you in a second. Associated spring plate, spring plate, I actually modified that and I made my own hex nut, and because the shaft is not long enough for that spring. Maybe there's a shorter spring you can get. This was the one I got. That is a B44 slipper spring, part number 9739. The little steel hub is part number 7485, and that number is for the plates. The slipper hub 7485 are for the slipper plates. The pads are part number 9611, and the slipper spring adapter, I believe that's that little metal washer at the end, that's part number 91423. But basically, because the spring's long, I had to make this nut, which fits on a 4mm thread, out of some of this hex stock I had. This basically came threaded. It's brass. Got some light issues here. Let's see. You can see it down here better. Anyway, I turned these down on my lathe. They're kind of like wheel extender nuts, for, when you have the long extensions on your axles. Similar design. The one on here is a little different length than this. This is just a super long one. This is stuff I had laying around. But basically I had to turn that down to 5mm diameter. This, let's see. Not great. Anyway, this is a 6mm hex, which is odd size for toolkit, so I wish it was a 6.55 or a 6.7. I think 7 is the next size up. Let's see. Yes, 7. It's not a 7, but if you have a little wrench, you can get in here and turn that with a 6. So I turned that down, and I had to bore out that washer to 5mm, just over 5mm, so I could slip this through it. And because the snout is short for this, but it all worked out. And the way I adjusted it, initially I was like, oh, I'll crank it all the way down, and I'm thinking, well, the only mechanical advantage here is the pinion teeth compared to the spur teeth. The motor, this is the lowest level of mechanical advantage in the drivetrain. Obviously, you get all of it out at the end because you have this gear set, an internal gear set, and your differential gear set all multiplied together. This is 87 tooth, that's 18 tooth. What's that? Do the math. It's like 4 to 1, right? Approximately. So I said, okay, now I'm gonna, you know, the only real reason I put this on here is because I don't like the plastic ones. They're ugly. They look cheap, and I keep seeing slipper clutches. So, and you know, mainly, I don't want to break pinion gears. I've been breaking pinion gears in my CRO one because there's no slipper clutch, and they're not machined steel. They're like a cast Tamiya metal. So I actually uncranked this down so that I could get some slippage, because I don't want, if these wheels get trapped, I don't want this thing flipping over. I don't want that kind of force going through into my pinion gear or anywhere else. I want it to slip. So I backed this off, and I'll play around with it as I get this running. But I don't think you need a high amount of compression on the spring. This spring is heavy duty. It could be like a 500 pound per inch spring. So you can get a lot of compression just cranking this down a hair. So we'll play around with that. So yeah, and you know, maybe I'll do an update video on the CR1 because that's gone through a bunch of changes too, and it's driving really well. But like I said, I'm breaking pinion gears. I just replaced both pinion gear sets in it. Last weekend, 2 weeks ago, it was nice weather, so I went out on the wall, broke the front, had one laying around, a spare, replaced it, went back out the next day, broke the rear, so then I had to order spare parts. Luckily, the new parts that came in looked like a better quality. They must have retooled that part. The pinion gears looked, just in general, like the color was a little different. They looked crisper. There wasn't any weird casting artifacts on them. They just looked nicer. So I think they did a better job with the new tool. Anyway, we'll get back to this. So, and that's what got me thinking about this slipper clutch, because I may upgrade it with one of these transmissions and this clutch. But I keep going back. Yeah, I need to do something with this rat's nest. I'm not done with these rocker panels. They're pretty nice. I like the way they look underneath. They're pretty smooth. You can see all these holes. This hole, this hole, this hole, and this hole actually mount it. This is a through hole, so you can pull the control arm upper mount bolt out of this hole. That's the idea. These don't encapsulate the part. You can, and they're not hidden, so you can unscrew this, pull it out if you need to. Yeah. So based on some other guys that are run this truck a lot, I did the caster change. So I clocked the caster back, and you can see the alignment marks, how they're almost aligned, but so the alignment mark on the C-hub is actually is below the line on the axle, and so it accentuates your steering ability. But when you do that, you have to relocate the drag link to above the steering arm. When I did that, for some reason, it became too long, and I had a lot of toe ends, so I replaced the rod ends with some short Traxxas rod ends on here, and was able to get my toe-in adjustment correct again. I can't figure out why. I think, you know, if you look at this, so I think there's some camber. There's some camber on this, and that means that now that I'm looking at it, it means that the tire, the knuckles basically lean inward on top. So when you go from below the arm to above the arm, you're basically, you have a taper. You're tapering up. So that mounts that were here on the below are now closer up top. So that's what it is. I didn't realize that at the time, but that makes sense to me. I haven't run this truck a lot. I took it out one day when it was wet and slippery, and I didn't spend a lot of time on the wall because of the conditions. But I didn't have a bumper on it at the time, and now I do. We'll see if it holds up. It's just PLA Pro, just like these, and this battery mount and the rocker sliders. That's basically my update on this. I am running the Noble. I did pull the power wire off from the ESC because of the BEC. I do want to make a electronics tray, or I can't use the stock electronics box because it doesn't fit anymore now that the Artful Dodgers mount kind of made everything fat. In this body, it won't fit in between the body and the new position of the motor and the transmission, so that is kind of that. All right, thanks for watching, if anybody's watching, and I'll see you with another update on the other crawler. Thanks.